Hello everyone, welcome to the video. This is section 2.1 where we're going to be looking at conditional statements. So chapter 2 is where we start um, piling up information, and eventually we're going to be able to write a formal proof. One of the first things that we get to look at is conditional statements. We'll go, in other slides, stuff like that, we'll go into what conditional statements are. But what question we're going to ask ourselves is, when is a conditional statement true or when is a conditional statement false? Basically, when a statement is true, which means it's true in every scenario. You can say a conditional statement is false when you can pick just one scenario where it is untrue. So in some instances, it's a little bit more challenging to find, um, you know, conditional statements that are true. It's a lot easier sometimes to find conditional statements are false because you just have to find one scenario. But with the true ones, you have to make sure that they're true in every scenario. So looking at a definition of a conditional statement, it says it's a logical statement that has two parts. It has a hypothesis, which is denoted by the letter P. I don't know why, but it is, and a conclusion Q. Again, I don't know why they use those variables. When a conditional statement is written, it is used in an if-then form. If contains the hypothesis, and then contains a conclusion. So in words, it's basically going to look something like this. So if the hypothesis, whatever that happens to be, then you're given the conclusion. Okay. So let's take a look at some examples. So here it says they want us to use red to identify the hypothesis and blue to identify the conclusion, then rewrite the conditional statement in if-then form. So if you don't have red or blue, just identify which one's the hypothesis and which one's the conclusion. So in this particular example, it says all birds have feathers. So normally, it's not always, normally the first item that is given is usually the hypothesis. So they're saying that hypothesis is going to be in red. So birds are, or more likely all birds are in red. Conclusion they said was going to be in blue, and it's usually the second part of the scenario, and they're talking about having feathers. So if you were to rewrite this in if-then form, it's going to look something like this. Now, there's different ways you can write it, but this is probably the most accepted way to write it. So it said because a bird is an animal, you can say that if, because it has to start with if an animal is a bird, then it has feathers. So that's how you would write that statement in if-then form. Looking at the second example, it says you are in Texas if you are in Houston. So in this one here, if you notice, they have the word if there. So that's probably an indication that the second thing is the hypothesis. So in this case here, Houston is our hypothesis and Texas is our conclusion. All right. Again, it's not normally uh, the second item in the phrase or in the sentence, but sometimes it is. And having that if there is a big indicator. So rewriting this in if-then form, you would write it like if. Oh, it's fine. If you are in Houston, then you are in Texas. Okay. So one of the things that they're going to talk about, which would we didn't touch on it, talking about if the conditional statement is true or false. So off the top of my head, I can't think of any bird that doesn't have feathers offhand. I'm sure there is as a scenario, but for right now, let's make the assumption I can't think of anyone. So I would say that this would be a true statement. If you think of a bird that doesn't have feathers, please comment down below. Um, I just can't think of any at the moment. But the second one, it says, if you are in Houston, then you are in Texas. Well, you could be in Dallas and be in Texas. So, um, well, I guess if they wrote it, I guess if they wrote it as, um, if you are in Texas, then you're in Houston. That would make it false. So I would say that is also true, unless there's another city named Houston that's not in Texas. All right. So here again, it says use red to identify the hypothesis, blue to identify the conclusion, then rewrite it in if-then form. So same idea as before. What I'd like you to do is give it a try, and if you are struggling, please comment down below. I'm more than happy to. I'm more than happy to show you this example. Next item or next term that we're going to be looking at is negation. All right, negation. What the thing that I always use is it's the opposite of the original statement. So anytime they want a negation of of a of a statement, you're just going to use the word not in front of it. On the flip side, if they already use the word not in the sentence, then you just, replace it without the not. So the examples that we're given here, it says write a negation for each statement. Here it says the ball is red. So I'm just going to attach a not to it. So it's going to be the ball is not red. Here, this is where they have not already in there. So to make a negation, you remove the not. So this is going to be the cat is black. So this here is, for the most part, a majority of our findings in this particular section, because you have to be really, really careful and when you are writing these statements to make sure that they are consistent with the original conditional statement um, and then because a lot of people make mistakes is not necessarily not knowing what term it is, it's just mixing up hypothesis and conclusions. So the first thing is the conditional statement in if-then form. It's you got hypothesis P and you have conclusion Q. So it's if hypothesis, then conclusion. If you are asked to write a converse of the conditional statement, you are basically flipping the you're basically flipping that original statement. So then you're placing the hypothesis in the if statement and the conclusion in the then statement. Okay. Inverse That's with negation involved. So it's going to be using the original conditional statement right here, where hypothesis P and you have conclusion Q, but then you write not in front of it. And then finally, you are going to write essentially a negation of your converse. So let's take a look at an example here. So it says, let P be you are a guitar player, and let Q be you are a musician. It says, write each statement in words and decide whether it is true or false. So the conditional statement is if you are a guitar player, then you are a musician. All right, is that true? Yes, yes, it is true. If you are a guitar player, then you are a musician. So now you're going to write the converse. So now you're just going to put the conclusion or Q with the if statement, if part, and put our hypothesis with the then part. So now it's going to be written as if you are a musician, then you are a guitar player. That is false because you could be a drummer and still be a musician. All right, so I figured out one scenario. Inverse. Inverse now is you're going to replace this statement here, the conditional statement, when putting nots in front of uh, both the hypothesis and the conclusion. So here is if you are not a musician, then you are not. Oh, I'm sorry. I wrote it wrong. See, I already screwed up. I got to use the first one. Let's see. I make mistakes too. If you are not a guitar player, sorry about the mistake, then you are not a musician. So in this one here, if you are not a guitar player, you're not a musician. Again, that's same. You can say like, well, I'm a drummer. That doesn't make me not a musician. So this would be false. And then finally, the contrapositive is the inverse of the converse. So I'm going to be using statement B to help me out. So I attach not to that. So this is going to be if you are not a musician, then you are not a guitar player. And that is true. If you don't play any, if you're not a musician at all, then you probably don't play guitar. All right, so here they ask us to decide whether each statement above the diagram is true. They want us to explain your answer using definitions that you've learned. So here in part A, it says line AC is perpendicular to line BD. So this symbol means perpendicular. Looks like an upside down T. Um, I can say that yes, this statement is true. How can I explain this statement? Well, I know that right here we have a right angle symbol. All right, that right angle symbol means that that angle is 90 degrees. for something to be perpendicular, it has to equal 90 degrees. So that would be like my definition. Okay, I'd have to write that out, but I just explained it. Here it says uh, angle AEB. So let me, AEB is right there, and angle CEB is right there. Are they a linear pair? Yes, they are a linear pair because by definition they are uh, two angles, that have a common endpoint, a common ray or common line. So yeah, they are in fact a linear pair. C, it says, is ray EA and ray EB opposite rays. Uh, that one is false, so this would be like no or false. The reason why is because in order for them to be opposite rays, um, you'd either have to say, you could make an argument like, well, ray EA and ray EC are opposite rays, or you could also say like EB and ED are opposite rays, or say something along the lines of like E is not on the same line with A and B, something to those extent. All right, so kind of similar situation. They want you to see if this statement is true or not. Again, um, I encourage you to give them a try yourself. If you have questions, please comment down below. More than happy to help out if needed. The last thing that we're going to cover here is biconditional statement. Biconditional statement means that if you are given a conditional statement and you are given a converse of that conditional statement, and you can say that both statements are true, then you can rewrite it as a biconditional statement, which means that you're going to contain the phrase if and only if. All right. One one thing that people make a lot of mistakes with writing a conditional statement is they want to use if then. All right. Don't do it. All right. So remember that it's not writing as a conditional statement. You're writing as a biconditional statement, which means that you're just going to write it as a phrase, and then in the middle you're going to write the words if and only if. All right. Here's an example. So here it says uh, rewrite the definition of perpendicular lines as a singular biconditional statement. So before I write it as a biconditional statement, I'm going to write it as a converse, okay? Because right now we have this conditional statement of if two lines intersect to form a right angle, then they are perpendicular lines. So if I wrote this as a converse, you would write it as if two lines are perpendicular, then they intersect to form a right angle. So you have to ask yourself in both of these statements, are they true? First statement is true. If you intersect, if it intersects at a right angle, they're going to be perpendicular. That's kind of like one of the examples that we talked about in a couple of slides previous. And then if I look at the converse, it says if two lines are perpendicular, then they intersect to form a 90-degree angle. All right, so that is also true. So this is a unique situation where both um, the conditional statement and the converse is both true statements. So like looking at the musician one here, this one you couldn't write as a biconditional statement because the conditional statement was true, but the converse was false. So I couldn't write it as a conditional statement. So looking at this, writing it as a biconditional, again, not using if then, it's going to look something like this. So I basically eliminate the if. So I'm going to write 2 lines, form, right angles, and I always use the original hypothesis. And then instead of writing then, you're going to write if and only if they are perpendicular lines. Okay, so there's the if and only if right there. All right, and that is uh, looking at biconditional statements. Hope this helps. Till next time.